Hi everyone. So now we continue our session. In the previous session, I've explained concerning the fundamental logic of regression analysis, which essentially try to find the best fitting line for the scatter plots between the independent and dependent variable, which leads us to the minimum prediction error here in terms of the squared prediction errors overall. Yeah. The problem is then how to define the regression functions, which then will lead us to the minimum squared error of prediction. Yeah. In other words, how can we calculate the value of the regression functions constants such as b null and b1? Yeah. So in terms of manual calculations of those value, we have this formula here. Yes, because because y is equal to an intercept which is b null plus b1 x1. Then b null, of course, if we switch the b null and the y, then the b null equals to the y bar minus b1 multiplied by x bar. Yeah, and then we can calculate what is the value we know if we have the average value of all of the dependent variables. So we make a summation of all the dependent variable divided by the number of data set, yeah, not the number of data, or the average value of the dependent variable. And then we also here have the x bar, which means the average value of the independent variable times b1. Yeah, but of course, yeah, since we don't know, yeah, in determining b null, since we don't know yet what is b1 is, then we need the formula of b1. Yeah, computationally, b1 is yeah, the division between ssxy divided by ssx. Yeah, ssxy, yeah, we will have the ssxy using this formula, which is a summation of multiplications between the independent variable and then the dependent variable minus the summations of the independent variable multiplied by summations of dependent variables divided by the number of data. Yeah. So this is for xsxy, and then xsx ssx, yeah, equals to a summations of the squared value of each of the dependent variable minus summations of all of the dependent variables. Then we square it and then divide it by it. Okay, I think it's quite complicated formula, but we will demonstrate how to calculate the regression coefficient manually through a problem set example. Yeah. So this is the problem set. Yeah. So let's say that analyzing the relationship between advertising budget and sales, the owner of a custom bike shop decide to look at the monthly advertising budget and the sales data. Yeah. So we have a custom bike shop. Yeah. And then the owner of it, the owner of the shop would like to estimate the sales. Yeah. So how big is the estimated sales if the business owner spent 50 million rupees of advertising budget? He would like to yeah, make an estimation. If I spend 50 million rupees on ads budget, how big the estimated sales will be. Yeah. In doing that, see the business owner, yeah, can look to its historical records concerning the pairing between the advertising and the sales budget. For example, for last January, month number one, the sales shop spent 23 million rupees in advertising, and then the sales that they gain during the month January is 960 million. Yeah. February they spent 46 million rupees in advertising budget, and the incoming sales that they gain is 1.130 billion rupees, and so on. So based on this data, the bike shop owner would like to estimate, okay, if I would like to have 15 million rupees in advertising budget, if I spend 50 million advertising budget, how much sales I will get? In order to do that, I will give you a demo. So just a moment, I will use Microsoft Excel here. So we have the data like that. I will just make a copy paste out of it. You could see, I hope you can see it clearly. And then we would like to build the regression function as a means to calculate the estimated sales from the advertising budget. The first step that I usually do is to make a scatter plot. Just to see, to get an intuition whether the relationship between the independent variable, which is ads budget, and the dependent variable, which is sales budget, is indeed can be identified as into a linear relationship. So what we will do is, we put insert here, and then we add a scatter plot chart. Here we can see. Let me make it clearer. So you can. I will put an axis so it's becomes more clearer to you. Sorry. I will add here axis titles. So here sales. Mil rupiah. And then here is ads budget million rupiah. By seeing the scatter plot, we can already we can see a bit. Seeing the scatter plot, we can try to make sense. We try to subjectively to see whether the scatter plot can be approached with using linear relationship or not. So as you know, there are actually many relationships in analyzing a relationship between dependent and independent variable. You can use linear, you can use curvilinear, or other functions, logarithmic and so on. But here, after seeing this, actually, I think it's pretty reasonable if we identify it into linear relationship. To make it clearer, I would like to add a trend line here. So you can you can use logarithmic, this one, polynomial, power, moving average, but I choose linear regression. The linear relationship. So actually, it's rather makes sense that the relationship between independent and dependent variable to be approached with linear relationship. Yeah, I think it's quite okay. So like this. Okay. Yeah. So what the first thing that I do usually is, building a scatter plot. Yeah. And then after we have the scatter plot, and then decide that okay, I will approach it with linear regression, or linear relationship. Then of course the function of it, the function of the line will be represented with this, y equal b null and plus b1 times x1. Yeah. But the problem is then how can we decide what is the value of b null and b1? Yeah, that's a challenge. Yeah. So I will just copy paste the formula to my Excel sheet. Yeah, just to make it easier for you to follow. So b1 and also b null. Let me see. So I have here copy. Yeah. So after seeing this, yeah, let's calculate b1 first. Yeah. So we have x1 and then we have x and y1. Yeah. And for calculating b1, we need xy and xx. Yeah. For calculating xx, we need this value. Yeah. x1, and then you make a squared value out of x1. Yeah, so let me calculate the x1 squared first. Yeah, x1 squared. I type it here. Yeah, and what you do is you simply make a squared function of each of the x1 value, and then put it here. Yeah, here you have the x1 square value, and you drag and drop it. And then what do we require in SSX here is the is the summation of the x1 square. Yeah, so I will just a moment. No, sorry. So I will, to make it clearer for you. Yeah. This moment, I will put x1 squared here. Yeah. Then it's a summation of all of the x1 squared, which is like this. Okay. Okay. So we have already acquired this value, and then the other one that we need is x1. Yeah, x1, and then the summation of x1, which is you make a summation of all x1 here. I will make it here. Yeah. And then you try to square it. Yeah. So I will also do the same thing to make it clearer for you. Yeah. Just a moment. So here is the value of sorry, the value of summation of x1 xi. Yeah. Okay. After we have this value, and then we have the m value, which is equals the number of the data, which is 12. Then we can already calculate SSX. Nah? How we calculate it? Of course, I will put it here. Just a moment. Yeah. Once again, I will use Paint just to make it easier for the demo. Yeah. SSX, Bismillah. Yeah. Yeah. So we have SSX here as a formula. Yeah. And what is the what's inside it, equals to x1 squared, this, yeah, and then minus, right, summation of x1 like this, and then you square it, right, square it, and then you divide by the number of the data, right, which is 12. You have this, yeah. So here we have SSX, yeah, just put it here. If not, I put it here. Yeah, sorry, pam SSX. Yeah, so we have the value of SSX here. Yeah, and then for B1 we are not only require the SX value but also SSXY. Yeah, if we see, so I will just copy paste the formula. Sorry, just a moment. Here, yeah, to make easier for us, to make it easier for us. Yeah, so I put it here. Yeah, here what they are trying to do is, you know, SSXY equals to summation of xi times yi. Yeah, we don't have the value here yet, but since we need it, then we of course we calculate it. So xi yi here, pump, yeah, equals, yeah, you multiply the xi value with the yi value, pump, yeah, and you drag it downwards, yeah, and then for the yi, of course you make a summation out of it, because here is summation of xi yi, yeah, auto sum. Here you have the xi yi, yeah, so we have this value. The next thing is we need this value, yeah, which is xi summation of it. We have it already, but we still don't have the yi, yeah, so we need that. Okay, so let's just calculate it. I think it's also easy, but I would like to copy the formula first, because to make it clearer for you. Yeah. Okay, home. Yeah. Okay, so I have it here, right? So xy, how to use it, how to calculate it is easy. You make an auto sum out of what, all of the yi values, and then here we have it. Yeah. So in terms of value, we have already all the required variable here, right? Why? And then what we're trying to do is, yeah, just input the values then. Yeah, sigma xy, we have it here, and then minus sigma xi, this, times sigma xyi, this, and then divided by the number of data, right? Then we have this value. So the SSXY equals to 48,022. Yeah. Then, of course, after we have the SSX and SSXY, we can now calculate the B1. Yeah. Which is just a moment. B1, yeah, I will make it clearer also here. Yeah, the B1, sorry. here, yeah, equals to SSX y divided by SSX. Then B1 equals to SSXY divided by SSX, which equals to 5.82. Yeah, so this is the value of B1 for the regression function. Okay, now we are done with the B1 calculation, right? I will delete this. No, just let it here so for reference. Now we need to calculate the B-null, and the B-null calculations is here. Yeah, formula is like this, so it's not that complicated, it seems. I will just rewrite the formula here. Yeah, so B null equals to the means value of y minus B1 times the means value of x. Yeah, so we have a summation value here, but we still don't have the mean value of x and the mean value of y value. Yeah, that's why let's do it. Yeah, so for the x1, just a moment. For the y bar value, which means the mean value of y variable is of course, we can simply make an average out of all the data here. They can drop until there, and you get the y bar value of 1208. Yeah, and also for the x bar, of course, the same. Yeah, I just copy paste it to our associate. Yeah. How we calculate it in Excel, of course, equals to average for the value. Yeah. Then we have 151.08. Yeah. Here we are. So how to calculate B1? B-null, yeah, B-null is simply as easy as equals to the mean value of y, which is this, yeah, minus B1, yeah, minus by B1 we have already calculated here, times the mean value of x, which is here. Yeah. So we have the value of 110. Yeah. So there. So here we are. We have already calculate all of the constant, I think. Yeah. Sorry. So we have B1 and B0. Yeah. So the regression function which will come out of it, yeah, is what? So we have the function of, the generic function is y. To predict y is equal to B0 plus Bi times xi. And then, B0 equals to 5.82. And then B1 is equals to 910. Sorry, I flipped. So B0 is 110 and B1 is 5.82. Then the regression function, the best linear fitted function is, so yi equals to 110, this one, plus 5.82, times x1. So this will be the regression function. Yeah. So that's the manual calculations of the regression function. manual calculation, how to get the constant of the regression function, how to check it to if it's right or not. So actually, that's very interesting questions, yeah, because now you understand how to conduct it using manual step-by-step approach, yeah. But actually, if in Excel, yeah, there's already a embedded function in which you can, yeah, you can show what the regression function is by you can click the line and then you right click the line, yeah, and format trend line if I'm not mistaken. And then here you can checklist this this option, display equation on chart. Here, so we have the equations, and as we can see here, yeah, I will make it larger. Yeah, the Excel suggests that the regression line will be 5.8231 plus 910. Yeah, so here is also the same like our calculation. Yeah, y I equals to 110.04 plus 5.823. Yeah, so it's equals with our calculation, which means that our calculation is right. Yeah, so thank God. Okay, now back to the questions. Okay, now we have already the regression line. So how, yeah, and then, yeah, we calculated using Excel, yeah, step by step. Yeah, this is the manual, yeah. And then what does it mean actually? Yeah, with this function. See, sorry. So 910.05 plus 5.82x. Yeah. So yeah, it means that, yeah. So I rewrite it here. Yeah, 5.821 plus 1. Yeah. The slope of B1, so B1 is the constant of the independent variable, is 5.82. Yeah, which means for each increase of 1 unit in X, the predicted value of Y or sales is estimated to increase by 5.82 units. So if you increase the sales budget, for example, 1 million rupees, yeah, then the multiplications effect will be 5.82. So if you spend 1 million budget in advertisement, then the sales, yeah, the corresponding sales will increase 5.83 million rupees. So in other words, for each increase of 1 million rupiah ads budget, the sales are estimated to increase by 5.82 million rupees. Yeah, so for each, yeah. So if it's if for example you spend 10 million rupees, then the sales will be, the increase of sales will be 10 times 5.82, which is 58 million rupees. Yeah, so that's the meaning of B1. Yeah, and for this one, the value of 910.04, which is B null, yeah, means that the y-intercept represents the predicted value sales when the S budget equals to 0. Yeah, so if you spend no advertising budget whatsoever, the sales will still reach 910 million rupees. Yeah, so if you spend no advertising budget at all, then the end sales will result to 910 million rupees. Yeah. And for the example, and then okay, now we have the regression function like this, and then what? And then we come back to the main question: how big the estimated sales if the business owner spent 50 million in advertising budget? Of course. So we have the regression function, yeah, y equal this, yeah, 910 plus 5.82 times the advertising budget, yeah. And then if we spend 50 million, then we just replace the xi with 50 million, yeah. And then the end sales will be predicted as 1,201 million rupees, yeah. Thus, yeah, for this specific question, how big is the estimated sales if the business owner spend 50 million advertising budgets, yeah, the estimated sales will be equals to 1.201 billion rupees. Yeah, I think that is my explanation concerning the manual calculations of the regression function. In the next session, I will discuss concerning the coefficient of determination, the coefficient of determination variable. What is it? Yeah, in regression function. Okay, I stop this session here. Yeah. Okay. See you in the next video. Bye.